Assalamualaikum. I'm Anuar Mohamed, EA18122. Now I'm going to present about soil moisture sensor. As we know, the soil moisture sensor uses capacitance to measure the water content of soil by measuring the dielectric permittivity of the soil, which is a function of the water content. So simply insert this rock sensor into the soil to be tested, and the volumetric water content of the soil will be reported in percentage. So let's move to the project assignment. Assalamualaikum warahmatullahi wabarakatuh. My name is Anuar bin Mohamed, ID EA18122, section 2 from Mr. Badaruddin. And what I'm gonna do about my assignment is about I want to measure the soil moisture using the soil moisture sensor. So what does soil moisture sensor does? Basically it is pretty straightforward. We have two shape probe like this, and will act like a variable resistor. Or we can say, in this case, we can use the potentiometer as our variable resistor. So the working mechanism of the soil moisture sensor is, when there is water, when the soil is wet, that means the resistance is low. When the resistance is low, so the voltage, the output voltage, will be calculated according to the value of resistance. So when the soil is dry, that means the resistance is high. That means the output voltage also will be high. Or we can, in this case, we can say that maximum at red, minimum at green. So now I will explain about the plot diagram of my assignment project. This is my plot diagram, as you can see. So we have the battery as our power system. It will be supplied to the sensor, which is a soil moisture sensor, and will be supplied to our microcontroller and also my LEDs. So we have analog input as our sensor. We have a soil moisture as our sensor, and the analog value will be sent to the STM. Then the data will be processed and will be transmitted, will be converted to the output set, which is a DC voltmeter and also 3 LEDs. So we have a serial monitor as our display. And now I'm gonna present about the project. So now we're gonna start with the left side first. We have to enable the clock of ADC1, GPIO, A, PNC, and USART2, and then we need to configure the USART2 and the ADC1, and then after that we move to the while loop one, and the sensor will read the analog value and convert it to the percentage. So as you know, this is on the linear equation. We have the gradient of 0.001221, or we can say 1.2 milli. And move to the function A, and the function A will calculate the analog output, which is analog value from the sensor, and divided by 12 times 12 bit, and then the percentage will be calculated by 100 minus in bracket analog output times 100, and then the voltage is simply as a gradient times analog value, and then it will print on the serial monitor, which is voltage, analog value, and percentage of the moisture, soil moisture. And then it will move to the function bin, which consists of conditions, and we have 3 conditions here. If the voltage is less than 5 and more than 3.5, I'm sorry, this is more than 3.5, wrong sign here, and then the print message will be soil is dry, please water your plant, and the red LED is on. If the voltage is less than 3.5 or more 2 volt, this is wrong again, the sign here. So the print message will be soil moisture is normal and the yellow LED is on. And if the voltage is less than 2 volt, that means the soil is wet. That means the print message will be soil is wet and the green LED will be on. So, and will that's it for the flowchart. So I'm gonna show you my coding first before we move to the Proteus. And first we have to declare our GPIO A, B, and C, and we have to declare our clock for USRT and also ADC1. So this is the declaration just according to the book from Dr. Irol. And the default mode, which is the initial mode, will be the LED will be turned off, and in the while loop, the analog value will be recorded by the sensor, and will be sent. The data will be sent to the STM32, and then based on the linear equation, what I get for the gradient is 1.221 milli, and for this voltage value, how I get is the gradient times the analog value, since the y-interception is 0, so there is no need to add 0 at behind. So the gradient will multiply by analog value. So to calculate the moisture percentage, what I do is 100 minus by analog output, which is analog value, over 4095 of which is 12 bit, times 100. Then I get the moisture percentage, and then all three data, which are analog value, voltage, and the moisture sensor, will be displayed on the serial monitor. And we have the condition here: if the voltage is less than 5 volts and the voltage is more than 3.5 volts, that means the soil is dry. And we have message here: please water your plant. And green LED will be, this is a red LED. The red LED will be displayed meanwhile, if the voltage is less than 3.5 and the voltage is more than 2, that means the soil moisture is normal, and the yellow LED will be turned on. Meanwhile, the other two will be turned off. And else, if the voltage is less than 2 volt, that means the soil is wet, which is good condition, and the green LED will be turned on. And the other function are just for the USART, for the data check transmit, and the check receive. And the other is the struct file for the serial monitor, when we use the standard input-output library. So that is it for me. So last part we will move to the Proteus. So let's go. As you can see, the voltage here on the Proteus displayed 5, and the serial monitor was displayed 5. When the voltage is 5, that means the soil is dry, so the moisture percentage is 0, and the analog value is high also, because the variable resistor is at maximum value. So please water your plant, and the red LED will be displayed. So let's move to the middle part. So when the voltage is 2.85, so the yellow LED will be turned on, and the soil moisture will be normal. Is normal, and the moisture percentage at the moment is 43%. And if the voltage is 1.65 volt, which is here, and the moisture percentage is 67%, which is good, so the soil is wet. So this is from me. Thank you for your attention and concentration. I bid you good day. Assalamualaikum.